Step 2. Include functions for transformation of 2D array into convolution kernel and simplified 2D convolution operation. For example, two-dimensional array into convolution kernel and simplified convolution operation. For example, 2D array into convolution kernel and simplified 2D operation like this. Issue kernel then data output 2D convolution example. Two-dimensional convolution. For example, two-D conversion using Python NumB A and B. Here also input kernel, intermediate output, kernel output. Input plus kernel into kernel output. Convolution for images. 2D conversions image. Example. Image kernel output. 2D image conversion with NumB. Input image pitch patch local specific field into conversion with the kernel, then output. This is the example. Diff make kernel A equal to NP as array A equal to reshape list shape plus 1, 1 return TF constant A, D type. That is conversion theorem together with the related theorems. Is one of the most important results of Fourier theory, which is that the convolution of two functions. Here convolution input and kernel convolution. Real space is the same as the product of their respective Fourier transform. And the Fourier series Fourier space. This one example for definition for one of the definition for convolution theorem. Diff simple convolution x, k simplified 2D convolution operation x equal to TF expand dimensions TF dot expand dimension x, 0, -1 output TF depthwise conversion to the x k 1111 paid is same. Return y equal to y of 00. Differential Laplace transform. Next one, Laplace transform. Laplace transform is the integral transform of the given derivative function real variable to convert into complex function with variables for t equal to 0. Definition f of t be given and assume the function satisfies certain conditions state to be stated later on. So Laplace we have to see the example of the Laplace. This is the Laplace. So better Laplace transform here or convolution. Compute the Laplace of an array Laplace k make kernel 0.5 1.5 1 minus 6 1 0.5 1.5 3 cross 3 matrix. Return simple conversion of x Laplace k. So here Laplace 2D Laplacian of array. Sorry. Compute the 2D Laplacian of an array. For example, applying Laplacian filter using 2D. This is the one of our example. Laplacian filter calculated like this way. Computation Python. Computation of discrete Laplacian. In Python, NumPy gradient of query. Python peak reduction in Laplacian matrix structure. Efficient acceleration of stencil. Numerical solution of Laplacian transform. Example. So like this. So session TF interactive session include the number of iterations and compute the graph to display the records. Accordingly, n equal to 500. Initial conditions: some raindrops hit a bond. Set everything to 0. U unit initialize NP zeros of Nn D type NP dot float 32. UT initialize NP zeros N, N D type NP float 32. Here U, here U. Set everything to be safe. Some raindrops hit bond at the random points. For n in range 100, a comma b np dot random dot rand initialize 0 comma n comma 2 u underscore a initialize of ab equal to np random uniformly. So plot im show u underscore unit plot show. Parameters EPS time for resolution, damping for wave damping. Like this. EPS TF placeholder TF dot float 32 shape. Damping TF placeholder TF float 32 shape. Create variables for simulation state. U equal to create variables for simulation state. TF variable U of U underscore initialize ut equal to tf variable ut underscore unit initialize discretized pde update rules u equal to u plus ebs conversion with ut equal to ut plus ebs conversion with laplace u minus damping conversion ut operation to update state. Step equal to TF group. U assign of U minus U. UT assign U of UT. Here U. Here UT. Initialize state to initial conditions. TF initialize all variables. Dot run. Run 1000 steps of PDE. For I in range 1000. Step simulation. Step run of EBS 0.03 damping 0.04. Visualize every 50 steps. I 500 equal to 0. W equal plot IM show of E value. Plot show. The graphs are plotted as shown below. Save. Next, image recognition using TensorFlow. TensorFlow image recognition. Image recognition. You will see that physical meaning in good. Example for the image recognition. Here car, truck, car. Here car, image recognition. How to build an image recognition. Image recognition. Example. Image recognition. So image recognition. Example. Okay, na? So TensorFlow includes special feature of image recognition, and these images are stored in specific folder. With relatively same images, it will be easy to implement the logic for security purposes. The folder structure of image recognition code implementation is as shown below. GPC locally TensorFlow image recognition idea such dataset image logs like this. For here int underscore to underscore word underscore out dot pickle. This one. The dataset image includes the related images which need to be loaded. We will focus on image recognition with our logo defined in it. The images are loaded with the load data.py script, which helps in keeping a note on various image recognition models with them. Import pickle from